Hello, viewers. In today's session, we are going to discuss a very important and conceptual problem from vectors, right? And here we have to discuss this problem in which we are given two non-zero vectors, that is vector A and vector B, and we have to show that if vector A is orthogonal or perpendicular to vector B, then the magnitude of A plus B is equal to magnitude of A minus B, and vice versa, right? By vice versa, we mean that if the magnitude of A plus B is equal to magnitude of A minus B, then the two vectors A and B are perpendicular, right? So to solve this problem, we have to make use of an important concept from vectors, and the concept is known as the square of a vector is equal to the square of its magnitude, right? So let us start. So here we are given that vector A and vector B are non-zero vectors, right? Okay, so here we have two cases. So the first case is that we have to prove that if vector A is perpendicular to vector B, then the magnitude of vector A plus B is equal to the magnitude vector A minus vector B, right? So first we'll prove that if this is given, then this is to be proved, right? And in the second case, we'll prove that if this is given, that is mod of that is the magnitude of A plus B is equal to the magnitude of the difference of the vectors A and B, then the two vectors, that is vector A and vector B, are perpendicular to each other, right? So first we'll prove the part 1. When the two vectors are perpendicular, then the magnitude of A plus B is equal to magnitude of A minus B. And in the second case, if the magnitude of A plus B is equal to magnitude of A minus B, then the two vectors must be orthogonal to each other. So now let us consider the first case. So here we are given that the vector A is perpendicular to vector B, right? And when vector A is perpendicular to vector B, it means the angle theta between vector A and vector B is pi by 2 or 90 degrees. And in that case, the dot product of vector A and vector B must be equal to 0, because cos of theta, that is cos pi by 2, is equal to 0. So the dot product of vector A and vector B is equal to 0. And now we have to prove this statement. So let us begin with the magnitude of vector A plus B. Right? Now to move further, what we will do, will make use of an important concept in vectors, which says that square of a vector, square of a vector is equal to square of its magnitude, right? Square of its magnitude. So here, suppose we have a vector, say vector C, then the square of the vector C must be equal to the magnitude of the square of the magnitude of the vector C. So here we have the square of the magnitude of vector C. So here if we take A plus B as C, that is, let us take A plus B is equal to vector C, then we have here the magnitude of vector C. So now from this expression or this result, the square of the magnitude of vector c must be equal to the square of the vector c, right? And the square of the vector c may be written as the dot product of c with itself, right? So we have dot product of c with itself, that is c dot c, right? Now the vector c is that is a plus b, and here we have a square, and we have c dot c. So we have vector a plus vector b plus a plus b, right? So now we have the dot product of a plus b with a plus b. So let us take the dot product. So first we'll take a dot a plus b, then we have b dot a plus b, right? So here we have a dot a, then here we'll make use of the distributive property, and we have a dot b, then we have b dot a, and then we have b dot b, right? So now a dot a is written as the square of vector a, which is equal to the square of the magnitude of vector a due to this result, right? So here we have that is a magnitude of a square, and here these two terms get added because the dot product obeys the commutative law. So a dot b is equal to b dot a. So here we have 2 times a dot b, and here we have the square of the magnitude of b, again due to this result, right? So now here the dot product of vector A and vector B is 0 because we are given that vector A is perpendicular to vector B, right? So here this dot product is 0, so this entire term becomes 0, right? So we have simply the square of the magnitude of vector A plus square of the magnitude of vector B, right? So the square of the magnitude of vector a plus vector b is given by this relation. So now this relation one can be written like this, that is a square of the magnitude of a plus b is equal to mod a square and plus mod b square, right? Okay, so now to get the value of mod of a minus b square, we can replace the vector b by negative of vector b in this relation. So when we replace vector b by negative of vector b, so here we have the square of a minus b, and then here we have mod a square, which is the square of the magnitude of vector a, and here we have negative of vector b mod, that is magnitude square, right? And from vectors we know that the magnitude of vector b is always equal to the magnitude of the vector minus b, right? Except the direction, right? So if the vector b is like this is vector b, then negative of vector b it orients like this, right? Or the direction of the vector minus b is opposite to the direction of the vector b. So the square of the magnitude of vector b is equal to the square of the magnitude of negative of vector b, right? So this term is now equal to the square of the magnitude of vector b, right? So now we can see that from these two relations, the square of the magnitude of a plus b is equal to the square of the magnitude of a minus b, because both these quantities are equal to the same expression, that is mod a square plus mod b square. So now this square and this square get cancelled. So we are left with that is the magnitude of a plus b is equal to magnitude of a minus b when the two vectors are perpendicular to each other, right? So this is how we can prove the first part. So now consider the second part, right? So here we are given that the magnitude of vector a plus b is equal to the magnitude of vector a minus b, right? And we have to show that when this condition prevails, then the two vectors are perpendicular to each other. It means the angle between them is 90 degrees, right? So we have to prove that the two vectors are orthogonal to each other. So let us start with this expression. So here magnitude of a plus b is equal to magnitude of a minus b. So let us take the square of both sides. So we have the square of both sides like this, and now we can use this important result, right? So the square of a vector is equal to the square of its magnitude. So here we have the square of the magnitudes. So this the left hand side is replaced by the square of the vector, right? And here also we have the square of the vector a minus b, and in this case we have the square of the vector a plus b due to this result. So now the square of the vector c may be written as c dot c. So here we have the square of a plus b. So we can now write a plus b dot a plus b, right? So these are the important concepts. Here also we have a minus b dot a minus b. So here we are taking all the steps in a particular sequence. So now taking the dot product, we have a dot a plus b, then we have b dot a plus b, and similarly in the right hand side we have a dot a minus b, then here we have minus b dot a minus b, right? So now here we have a dot a, then we have a dot b, and then we have b dot a, and here we have b dot b, right? So this is b dot a, and then b dot b, then here we have a dot a minus a dot b, this is minus b dot a, that is minus b dot a, then minus minus plus, and we have b dot b, right? So now looking at the two sides, that is left hand side and right hand side, we can easily conclude that we have some terms which can be cancelled out, right? So this is the first one, that is b dot b is cancelled by b dot b. Similarly a dot a and a dot a. Then here we have a dot b plus b dot a, right? So the scalar multiplication of two vectors is commutative. So a dot b is equal to b dot a. So here we can write 2 times a dot b, right? And here also we have a dot b and b dot a, and here we have the negative sign. So we have minus 2 times A dot B, right? Okay, so here if we take this term to this side, we have 4 times A dot B is equal to 0, because 2 times A dot B plus 2 times A dot B is 4 times A dot B, and now we have A dot B is equal to 0 over 4, that is equal to 0. So we see that the dot product of A and B is equal to 0, and the dot product of A and B is 0 implies that the two vectors must be orthogonal to each other, that is the angle between them should be 90 degrees, because here vector A and vector B are given to be non-zero vectors, right? So the only condition or the only possibility that the dot product of the two vectors reduces to 0 is that vector A should be perpendicular to vector B. It means the angle theta must be pi by 2, right? So whereas this is how we can discuss or we can solve these type of problems from vectors.